Hi children, I am Mr.Prabhu R, mathematics teacher in Kumodoti Residence Center School, KRCS-Mr.Prabhu. Today we are going to discuss the problems on the real numbers, the last exercise, that is exercise 1.4. So here I have already written. So see the question. Without actually performing the long division, state whether the following rational numbers will have terminating decimal expansions or a non-terminating repeating decimal expansions. So here so many examples are written. So this is already in the textbook. So 13, first one, 13 divided by 3125, 17 by 18, 64 by 455, 15 by 1600, 29 by 243, 23 divided by 2 to the power of 3, 5 to the power of 2, 120, 7th one, 129 divided by 2 to the power of 2, 5 to the power of 7, into 7 to the power of 5, 8th one 6 divided by 15, 9th one 35 divided by 15, and 10th one 77 divided by 210. Yes, let us solve the problems. Yes, once again remember the definitions of terminating and as well as non-terminating, what I explained in the previous video. Okay, terminating means it is defined as decimal expansions or decimal number which contains the finite number of digits after the decimal point. What do you mean by non-terminating decimal expansions? So it is defined as the decimal number which contains the infinite number of digits after the decimal points, but the digits may be repeated. So that is why it is known as non-terminating, repeating or recurring. So that is why. Here all are the rational numbers. Now let us solve one by one. So condition apply here, what they are applied here? Long division. Without actual performing the long division process, we should classify which is the terminating and which is the non-terminating. Now for the first one. What is the number given here? 13 divided by like this. Okay, how you can consider whether it is terminating or non-terminating? That is, I already explained in the previous theorem, that is theorem number 1.5, 1.6 and as well as 1.7 also, in which we explain that x be any rational number that may be expressed at x is equal to p by q, where p and q are in some other integers and as well as co-prime. So that the prime factorization of the q is of the form 2 to the power of n, 2 to the power of n into 5 to the power of m is known as these numbers are in the form of decimal expansions. So that is why this is terminating. If the number is denominator is expressed in the form of this form, then automatically you can classify it as terminating. So that is why today's exercise problems. Now, so before going to these solutions, you must know the prime factorization method by using that. Observe here, numerator already look at 13. It is a prime number, so it cannot be factored further. So that is why you can take 3, 1, 2, 5. Factorize it by using factorization method. Okay, so last digit 5, you can divide it by 5. 5 6 the 30. 2 12 become 12. So 5 2s are 10, 5 5s are. Again it is the last digit 5, you can divide it by this one. 5 1s are 5, 6. Okay. 1 12, 5 2s are 10, 5 5s are. Again it is the last digit 5, you can divide it by 5. 5 2s are 10, 5 5s are. Again it is 5 and therefore 5. Okay. So 5 5s are 25, 5 1s are. So here all the factors of these 3 1 2 5 are, look here, 1 2 3 4 5. It can be expressed as 5 to the power of 5. So therefore 5 to the power of 5. Now consider if a given rational number is of the form p by q, where q is an integer and q is not equal to 0. So therefore q is of the form 2 to the power of n or 5 to the power of m, where n and m are non-negative integers. So that is based on that theorem, that is theorem number 1.6 and as well as 1.5. So we consider hence the denominator. Here the denominator is of the form 5 to the power of m. Here 5 is there. So the denominator contains in the form of 5 to the power of m. So that is why here the given decimal expansions. Suppose you can expand it decimal form or convert it into decimal form, you will get the number as terminating. Hence that is 13 by 3125 is terminating. So this is our solutions. Go through it. Very simple. Consider P by Q number 13 divided by 5 to the power of 5, and here first observe carefully, factorize it whether it is numerator or denominator. Here denominator contains the composite number, that is why I factorized it. Again we get some other number, that is prime numbers. So suppose it is in the form of 2 to the power of n and 5 to the power of m, known as it is of the form decimal expansions. Yes, exactly, terminating. So that is why 5 to the power of 5 came. So here denominator is of the form, that is q value is 5 to the power of m. M is a non-negative integer, therefore this number is considered as terminating decimal expansions. So this is the result what we get now. Okay, in the same way, go to the next. There are so many examples. In the same way, we can express. Next one, second one. I want to solve here. Look here, 17 divided by 8. Here also, very simple number. In 17 divided by 8, what happened? Already 8 is written as 2 to the power of 2 into 2 into 2. So that is why 8 is equal to 2 cube. Because 17 is a prime number, we cannot factorize it further. So that is why, therefore, your solution, what happens? 17 divided by 2 to the power of cube. So therefore, now consider here denominator of the rational number is of the form 2 to the power of n. We required decimal expansion should be terminating, means we required their denominator either 2 to the power of n or 5 to the power of m, or both, that is 2 to the power of n and 5 to the power of m. So here it is also same. Therefore the given number is of the given number, their denominator in the form 2 to the power of n, that is 2 to the power of n. So that is why this is what 17 divided by 8 is terminating decimal expansions. This is the result. Here clearly from these two examples we must understand, that is how we can classify the terminating and as well as non-terminating. Now let us take another example. Let me see anyone. For example, similarly you can solve these remaining examples, in which I want to show another one. Look here, already it is this one, that is 23 divided by 2 to the power of 3 and 5 square. So here it is directly, seventh one is terminating decimal expansions. It is terminating one. Why it is terminating decimal expansions? Their denominator, that is consider P, it is Q. Q is of the form 2 to the power of n and 5 to the power of m. So that is why this number is totally decimal expansion should be terminating. That is why it is a terminating decimal expansions. This one. In the same way, what happened this one for seventh one? Understand? So before going to result, first know the P and Q value. Suppose you want to factorize it. Here it is 129. No necessary to factorize it because already this number is factorized. We want to finalize the result based upon the denominator. So that is why here whatever they given, observe here carefully. Look here, 129 divided by 2 to the power of 2, 5 to the power of 7, 7 to the power of 5. You consider the theorem number 1.7. What it says, if x be a rational number, so x can be expressed in the form of P by Q, but Q is not either in the form of 2 to the power of n into 5 to the power of m, then it is a non-terminating repeating decimal expansion. It says, on the based upon that theorem number 1.7, based on that theorem, I would like to explain the given number, in which the denominator that is q, consider denominator q, consider q, it is of the form other than 2 to the power of n into 5 to the power of n. What I am going to conclude here, given number is, yes, of course q is in the form of 2 to the power of n and 5 to the power of n. But here one more number came over here, that is prime number, and its some powers are there. Not only this number, if any number, the q must be is other than this 2 to the power of n and 5 to the power of m. It means therefore hence the given number, that is 129 divided by 2 to the square into 5 to the power of 7 into 7 to the power of 5 is non-terminating. It is non-terminating decimal expansions. It is non-terminating decimal expansion. Why? Because it is of the form 2 to the power of n and 5 to the power of m, but other than also. It means it includes some other prime factorizations also. That is why we can conclude it as non-terminating. Here, this number is terminating, this number is terminating. Of course, it is also terminating, but it is not a terminating. It is a non-terminating. It is one non-terminating. Here, henceforth, you can solve by applying this method. Conclude the answer, that is whether it is terminating decimal expansion or non-terminating repeating decimal expansions. Now, okay, now second one in the same exercise, second main question. What it says, write down the decimal expansions of those rational number in the question number 1. So here already I written. So above which have terminating decimal expansions, means we have to convert the fractions into decimal form. That's it. But before going to converting, we should observe there whatever they given which have only terminating decimal expansions, means I already explained this one is terminating. This one is terminating. Similarly, we can solve the remaining problems. This one is terminating and this one is non-terminating. Okay. In the same way, someone are included here, terminating and non-terminating. So, due to the time constraint, I would like to explain one or two examples over here. In the same way, we can do the remaining problems. Whatever they given. First one again 13 divided by 3125. So now there they given. Without actual performing the long division method or long division process, you have to convert them, which is the classify them, which is the terminating and non-terminating. Here, express them in the form of decimal expansions. That the question is arises now. So for this purpose, we can use the long division process, that is 3125 can be written in the formal method, that is 13. Okay, divisor, dividend, and here it is quotient. Okay, of course it is. Now divisor is greater than the dividend. Always dividend is greater than the divisor. But here what happened? Dividend is lesser. So that is why consider 0. So 0 into something is 0. So therefore 30. Okay, now take the point. Put the point in the quotient. So automatically it becomes also point. Can take one more 0. 130 is less than that the divisor. So that is why you can take one more 0. So that become now 0. So here now 1300 here. It is now it is 3000 something. It is also less. That is why if you multiply it, you can get like this only number. So automatically point is there. You can put one more point. Now it is become 13,000. Means again put point 10. So 13,000 here is 3000 something. So now for this purpose we can calculate like this into something. Multiply this divisor and quotient. Okay, 3000 something. It is 13,000. 3000 tens are 30,000. So take lesser number that. Either take 5 3s are 15, 3 2s are 6 1 7, 3 1s are 3, 3 3s are 9. It comes approximately near but lesser than that number. Take one more number, 3 1 2 4 into 4. Okay, 5 4s are 20, 2 less, 4 2s are 8, 10, 1 carry, 4 4s are 4 5, 5 3s are 50. Automatically it is 15,500. 500. So which is the number comes now? Nearest number, that is 3. The quotient, take 3 because 3 5s are 5. 3 5s are 15, 1 carry 3 2s are 6, 1 7, 3 1s are 3, 3 3s are 9. Here it is 4 5s are 22, 4 2s are 8 plus 10, 1, 4 1s are 4, 5, 5 2, 4 3s are, sorry, 4 1s are 4 plus 1 5, 4 3s are 12. Yes, this is equivalent. So it is very lesser and it is lesser than that number also. But of course you can take one more, that is quotient number, there is 4 now. So what happened? It is more than that. So that is why. So take now 13,000 which is greater than 3,125. So which is the number over here? Take down 4. Okay, it is 12,500. Now subtract, we will get the number 5. So 0. It is 500. Now take point here, one more 0. So that is why we can again divide it 5,000. Okay, 3,125 into. We require 5,000, means lesser than that. Only 2, it become maximum because 3 into 2 is 6,000 something. So that is why take 1. That is 3,125. Subtract it, you will get 10 minus 5 is 5. So 9, 9 2 minus 7. Okay, here 9, 8, here 1 bar. So here 4, 3, 1, 1875. So again, so here 1,875, 3,000. So we can take one more 0 because of this point. So now it is 18,750. So for this purpose, we can multiply by some other number to the divisor. Which is the number? Already I took 4. 4 is equivalent to this one is 12 something. Okay, we require 18,000. I think 7 5s are 35. 7 2s are 14. 14 plus 3. 17, 1 carry, 7 1s are 7, 8, 7 3s are 21. It is greater than. That is why 3 1 2 5 into take 6, 6 5s are 30. So 3 carry, 6 2s are 12, 12 plus 3, 15, 1 carry, 6 1s are 6, 7, 6 3s are 18. Yes, exact answer came. So that is why it is divided. Yes, 3,124 into 6 is 1,870. So now your remainder must be 0. It means it ends. Their decimal expansion ends. Therefore, its decimal expansion is 0.00416. So that is why it is terminating decimal expansions. By using the long division process, we expand this p by q, means rational number, into decimal expansion. In the same way, you can convert this all terminating decimal expansions by using long division method. That is, the given numbers are here. Let us see the question number, last question of this exercise. That is, the following real numbers have decimal expansions. They given as given below. In each case, decide whether they are rational and of the form p by q. Means what can you say that about the prime factors of q? This is the question. Okay, of course, the given numbers are in the form of decimal expansions. What do you say about these prime factors of q if you express in the form of p by q? So consider first one. So first one, in which the given number here 43.1234567 consider any number also other than this also. So now whatever decimal, it is terminating. Of course, it is terminating. Why? Terminating. It is terminating. Why it is terminating? If we express this given number into p by q form, express this number into p by q form, that is I shown it in the previous exercise problems. So the number comes like this form, that is p by q. Of course, q, if it is a terminating decimal expansion, means q should be expressed in the form of 2 to the power of n into 5 to the power of n, or 2 to the power of n and 5 to the power of n. So that is why, because the denominator, this is of the form p by q, where q is in the form of 2 to the power of m or n 2 to the power of m into 5 to the power of m. So that is why given that terminating decimal expansions, the decimal expansions of this number is terminating decimal expansions. Therefore, given number or decimal expansion, given number is terminating decimal expansions. Okay, so this is our answer. The next one, second one. Okay, now second one. Given decimal expansions, of course it is a rational number, but how you say it is a rational or irrational? That according to based upon the previous theorem, that is 1.6, 1.7, what it says, if a given number should be in the form of p by q, their denominator q is of the form 2 to the power of n, 5 to the power of m, then only it is decimal expansion is terminating. Otherwise it is not terminating. Okay, but there is a decimal expansion should be repeated. Whatever what is going on here, it is 1 2 here after the point, decimal point. Observe here 1 2 0 1 2 0 double 0 came here, 1 2 0 double 0, here single 0 double 0 triple 0, means the digits cannot be repeated. The digits may not be repeated. Matte sersavanta. Yes, therefore if we express the given number into p by q, it shows us their decimal expansions q is not either of the form 2 to the power of n and 5 to the power of m. So that is why if it is not here q is not of the form 2 to the power of m into 5 to the power of m. So therefore given number is irrational. It is an irrational. Therefore it having the non-terminating and non-recurring expansions, decimal expansions. Once again, it is non-terminating, non-repeating decimal expansions. It is non-terminating, non-repeating decimal expansion. So this is our required solution. Okay. Now look here for the third solution, 43.123456789 bar. It represents these after the decimal point. These digits should be repeated. Therefore, this is so the given number is of the form p by q. Is of the form p by q, and hence q can be expressed in the form of 2 to the power of n into 5 to the power of n, and other than this number also. That is why it is non-terminating. And repeating. It is non-terminating and repeating decimal expansion. So this concludes our answer. Therefore, observe carefully the given numbers. Yes, once again, this number is decimal expansion is terminating. This number decimal expansion is not repeating, and it is considered irrational number. Henceforth, it is known as non-terminating and non-recurring decimal expansion. It is non-terminating but repeating decimal expansions. So this is about today's class. Yes, dear students, go through your textbook and try to solve the remaining examples of exercise contained in the 1.4. Thank you.